Human error is both universal and inevitable. This means everyone will make a mistake sooner or later. In fact, the best people often make the worst mistakes. When learning of an accident caused by human error, it's common to think the person involved is somehow deficient in skill or character, while we, on the other hand, are well-meaning, motivated, experienced technicians. We just wouldn't do something that stupid. When we think in these terms, we discount the moral of the story and miss the lesson in it. This is the picture of a spectacular accident caused by human error. The pilot started the loop at about 1,000 feet, 100 feet lower than he should have. Before takeoff, the pilot set his altimeter to his home base field elevation, Nellis Air Force Base. His action, perhaps, was the result of habit. The elevation of Mountain Home Air Force Base, the site of the flight demonstration, was about 1,100 feet higher than Nellis. Even though the mistake was slight, setting the wrong altimeter setting, the outcome was tragic. Here's the lesson. Does the Air Force select mediocre pilots for the Thunderbird demonstration team? Not likely. They choose only the best of the best. The reason the best people make the worst mistakes is they are assigned the riskiest jobs. The point is, you can be the sharpest person on your crew, but if you have a sleepless night or someone doesn't give you vital information, then you may make a mistake. It may be a very slight mistake, but in the context of aviation, even a very slight mistake can be disastrous, perhaps even fatal. Good people make mistakes because they're influenced by their organization, workplace, tools, and environment to do so. The objective of this presentation is to introduce 12 common issues that influence humans to make mistakes, and additionally, error capture strategies called safety nets will be suggested which may prevent common errors from having tragic consequences. So how do we prevent mistakes like this one? How do we break the chain of events that may well result in the loss of an aircraft, or worst case, a fatality? The Dirty Dozen is a poster series highlighting 12 preconditions for unsafe acts. In other words, factors that influence people to make mistakes. The series of posters was developed by Gordon DuPont while working with Transport Canada. It is not meant to be a comprehensive list. It is just meant to stimulate the human factors discussion. Lack of communication is the first human factors issue we will discuss. This communication example prompted the picture on the poster. It caused an accident that claimed the lives of 14 people. On September 11, 1991, a Continental Express Brasilia crashed in a cornfield near Eagle Lake, Texas. The horizontal stabilizer had separated from the fuselage, leading to a severe pitchover and subsequent disintegration of the aircraft. The upper 47 screws that should have attached the leading edge assembly to the left side of the horizontal stabilizer were missing. They had been removed the night before during maintenance. That evening, the job was to replace the de-ice boots on the horizontal stabilizer. The process was to remove the leading edge skins from the aircraft, then change the rubber de-ice boot while the leading edge was on the bench. The work was assigned to 2 shifts, swing shift and graveyard shift. 2 mechanics, with the help of an inspector, used a work stand to gain access to the T-tail of the aircraft, about 20 feet above the ground. The 2 mechanics removed most of the screws on the bottom side of the right leading edge. Meanwhile, the assisting inspector removed the attaching screws on the top of the right side, and then walked across the T-tail and removed the screws from the top of the left side. Later, he filled out the inspector's turnover form with the entry, "Help the mechanic remove the de-ice boots." He then clocked out and went home. Many other shift turnover briefings were given that evening, most of them informal and verbal. The point is the information about the screws being removed from the top left horizontal stabilizer leading edge got lost in the bustle of the shift turnover. At some point, the supervisors decided there would not be sufficient time to change the left de-ice boot that night. After the shift change, mechanics from the graveyard shift finished removing the right leading edge assembly from the horizontal stabilizer. A new de-ice boot was bonded to it at a workbench, and then it was reinstalled. Subsequently, the aircraft was cleared for flight. The first flight of the morning passed without incident. The accident occurred on the next flight. There's a lot more to this story. We've only skimmed the surface. The bottom line is those who needed the information didn't get it. In our struggle to make sense of the situation, we condense it to terms like poor communications, merging organizations, corporate safety culture. It may not be fair to distill the lesson to 3 safety nets, but what can we learn from this story that may help us contain our own mistakes, lest they have a disastrous outcome? Use logbooks, worksheets, etc. to communicate and remove doubt. Shift turnover should not only be written, but descriptive words should be used such as left, right, top, bottom, upper, and lower. Discuss work to be done or what has been completed. Discuss the work with the people who need to know. Make sure the person responsible for the aircraft's return to service knows the status of the aircraft. Never assume anything. Never assume your teammates know what's going on. Take responsibility to inform them yourself. Always check. Climb up the work stand. Remove the inspection plate. Ask teammates to explain. Complacency is caused by lack of sufficient stress. We hear stress is bad for our health, and too much unresolved stress certainly is. However, we need a moderate amount of stress for optimum performance. While too much stress causes confusion and fixation, too little stress can be a problem as well. It can cause a person to be bored and complacent. The following example is a case where a complacent person's mistake had dire health consequences. This accident involved the Italian Air Force in Keflavik, Iceland. The assumption is that they were traveling. Since they were away from their base, it makes sense that they would have lacked normally available resources. For instance, there was no lineman present for the startup. The loadmaster was asked to verify the battery door was closed after the engines were started. He agreed to check the door, and during the process he walked through the spinning propeller, which killed him instantly. It was the first time in 50 years this had happened to the Italian Air Force. More than likely they have procedures to prevent it. The loadmaster was probably used to walking around the aircraft with the engine shut down. He was experienced, as evidenced by his qualification as a loadmaster. Is it possible it was his habit to walk under the engine as he completed tasks around the aircraft? He is a perfect candidate for an error caused by complacency. Complacency is when you are so used to a task you can accomplish it without thinking. Was stress an issue? Traveling tends to stress people, but perhaps more to the point was the lack of stress. This was an experienced crew who knew their jobs. They could probably perform them in their sleep. If you do a job successfully hundreds of times, the tendency is to let your guard down. Complacency safety nets. Face reality. The reality we face in our industry is mistakes, even slight ones, may kill someone. Physical fitness. Physically fit people are more alert. People who are not healthy have a built-in distraction. They tend to feel bad, making it difficult to take the initiative to walk the extra mile, or even in some cases, do a decent day's work. Create challenges for yourself. Challenge yourself to find at least one fault per day. Never sign for anything you didn't do. This would be falsification. It's a felony. You can be pressured by human factors to falsify, but when you make the decision to sign for something you didn't do, it's no longer a human factor issue. It's an ethical decision. It may seem a lack of knowledge is about being inexperienced. However, the rational point of view is that aviation is incredibly complex. No one has all the answers. We all lack knowledge in tasks that are not familiar to us. Even experienced people need to refer to up-to-date manuals and ask questions. People can be very sharp and very well-meaning, but if they are untrained, bad things can happen. This happened at the Kuala Lumpur International Airport in Malaysia. Maintainers needed to taxi the aircraft from hangar to departure gate. They started the number 1 and number 4 engines, and they did not realize the hydraulic pumps were powered by the number 2 and number 3 engines. The brakes would have worked until any charged accumulators were discharged. The brakes more than likely lasted until the aircraft was lined up on the monsoon drainage ditch. Then these poor guys were on Mr. Toad's wild ride. The Boeing 747 rolled into the ditch and toppled forward, causing severe damage to the nose section. The aircraft was totaled. There were minor injuries to the crew. Lack of knowledge safety nets. Get training on type. Bad things happen to untrained people. Put yourself in the place of the maintenance crew taxiing the 747. They were trying to save the company money by saving hours, cycles, and fuel cost. Their motivation was not in doubt. Their method leaves a bit to be desired. They probably would have liked to know which engines pumped up the brakes. Stay current. Read not only up-to-date manuals, but trade magazines, websites, and human factors information. Your company may not have a human factors program. It may be up to you to find the information. Use up-to-date manuals. The aviation industry values continuous improvement. One of the main constants in aviation is constant change. I've been doing it this way for years is no longer a valid attitude. Ask a tech rep, What is the quickest way to lose the status of being the go-to guy in the crew? Forging ahead when you don't know what you're doing. When you break something due to your ignorance, you are no longer the go-to guy. Communicate. Let someone know when you need help. You will be respected for your humility. Our jobs and our lives are full of distractions. It has become a feature of our culture. A distraction shifts one's focus from the job at hand and increases the potential for perspective memory error or place-losing error. Distractions can come in many forms, such as noise, bright lights, people, radio messages, telephone calls, horseplay, and problems at home. This example of distraction happened to a group who supports missionaries in the bush with radios and aircraft. One day they were maintaining a Piper Aztec in Papua New Guinea. The scheduled maintenance that day was a 100-hour inspection. 4 mechanics were working together to accomplish the task. One of the mechanics was reconnecting the fuel hose on the right engine after inspecting the fuel servo finger screen. One of the other mechanics was having trouble timing a magneto on the left engine and asked for his help. He quickly finger-tightened the fuel hose and began helping to install the magneto. He then forgot the fuel line was loose. The inspection was completed and the aircraft was dispatched to haul freight and passengers. The aircraft had completed 2 legs of its first flight and had taken off on its 3rd leg when the right engine burst into flames. The passengers and the pilot were killed. This is another case where the best person made the worst mistake. Since we cannot easily eliminate distractions, we must accept them and find ways to cope with them. Safety nets for distraction. Always finish the job or unfasten the connection. In the case described above, finishing the job, torquing the B-nut, would have prevented the accident. The alternative, leaving the connection unfastened, would also have prevented the accident. The engine would not have started if the fuel hose was disconnected. Mark the uncompleted work. For instance, hang loose hardware in a bag attached to the unconnected component. Lock wire where possible or use torque seal. Lock wire or torque seal can provide a ready reference point when you return to the job. Double inspect by another or self. Inspection can uncover a multitude of mistakes. It's always helpful to ask for another person's perspective. When you return to the job, always go back 3 steps. When possible, this is helpful. If the work card will not allow consecutive work, or if the technician needs to skip steps to make the procedure work, the work card needs to be rewritten, and going back 3 steps may not help. Use a detailed check sheet. A detailed check sheet helps navigate when we become distracted. As mechanics, we are used to working alone, so the concept of teamwork can be a real change in thinking. Today we need to rely on our coworkers more than ever because, as time passes, aviation becomes more and more complex. On-time departures are very important for airlines. It is prudent to have wing walkers watching the action during the pushback. They are vital members of the team. There are times when airlines allow the tug driver to conduct the pushback alone because there are no wing walkers available. This is just such a case. Can you see the LAV truck parked behind the left engine? More than likely, this aircraft didn't depart on time. This is about $250,000 worth of damage. Safety nets for lack of teamwork include communicate. The team needs a clear purpose or mission. Never assume someone else knows what's going on. Take responsibility to inform them yourself. Team tasks require a full team. Missing team members can mean aspects of the mission will go undone. A short team meeting prior to commencing the job is a good idea. Reconfirm duties among the team members. During the short meeting, clarify expectations about the role of each of the team members. Each person in the team needs to know how they fit within the team. Follow the correct procedures. It is very important to follow procedures when working as a team. Your teammates expect you to follow the rules. When you don't, it makes a nasty surprise for your teammates. It is especially dangerous to violate procedures when working in a team because combining a violation with an error can create disaster. The question for people who violate is whose error will be the disaster trigger, their own or a teammate's? The effects of fatigue are common among aircraft mechanics, with many working 10 to 12-hour days. Fatigue degrades a person's ability to work effectively. Cognitive effects include memory loss, complacency, loss of coordination, lack of judgment, increased tolerance of risk, and impaired decision-making skills. Studies have associated sleep loss to blood alcohol levels. Would those who ask us to work tired tolerate us working drunk? There are three types of fatigue. The first two, acute and operational fatigue, are the same thing. They are caused by hard work and long hours. The difference is only a matter of duration. Chronic fatigue, however, requires medical intervention. It's another term for depression and needs at least counseling and possibly medicine. These are the symptoms of fatigue. These symptoms are true of fatigued people regardless of the category of fatigue they're experiencing. Chronic fatigue exhibits some of the same symptoms. The symptoms are often more evident to those who are working with the fatigued than they are to those who are actually fatigued. We have an internal biological clock with a cycle of roughly 24 hours. Many bodily functions cycle about these daily circadian rhythms, such as blood pressure, heart rate, core body temperature, and others. Perhaps more important to us is performance also cycles about normal circadian rhythms. The typical circadian cycle causes performance to peak between noon and 9 in the evening, and then fall to a minimum between 3 and 6 in the morning. The U.S. Marines became interested in the circadian rhythm. One group tried to reduce the effect of jet lag when they were traveling to the Persian Gulf. They adjusted their workday until it matched the workday of their destination. They then traveled to the Gulf. Much to their surprise, they arrived as jet-lagged as if they had not done the exercise. The reason is that the body clock is set by external synchronizers, such as sunrise, sunset, ambient temperature, meals, and other social cues. These markers were still active and did not allow the resetting of their internal clock. The point is, safety nets for fatigue are important no matter how long you've been on shift work. You'll just not be at your peak performance between midnight and 4 a.m. Fatigue safety nets. Be aware of the symptoms and look for them in yourself and others. Remember the symptoms: reduced attention, diminished memory, withdrawn mood, or low situational awareness brought about by long hours of labor or high-intensity stress. Plan to avoid complex tasks at the bottom of your circadian rhythm. Nice idea, isn't it? In a perfect world, this might happen. Perhaps the pragmatic point of view would be to understand you will not be at your peak performance in the nighttime, and compensate with any resource you can find. Resources like colleagues who can support you with help thinking through difficult situations. Perhaps they will also be willing to help with extra inspections. Another resource may be a slower operating tempo, allowing you to slow down and think through complex tasks. Sleep and exercise regularly. Practice good sleep hygiene. Try to sleep where it is quiet, cool, and dark. It is difficult to get a sound sleep when your circadian rhythm is at its peak. Exercise will generally make you feel better and more prepared to relax. Ask others to check your work. It is very difficult to avoid an action you did not intend to do. This makes mistakes somewhat invisible to those who make them. Someone else's point of view may uncover what you cannot see. Parts availability is certainly important. However, to expand the topic of lack of resources, what would be a list of important resources? Money, people, time, tools, data. This lack of resource came to light during the Alaska Flight 261 crash. It was not the cause of the crash, it was just discovered during the investigation. The accident aircraft's jack screw wear was measured by a tool not provided by the manufacturer. This would be a lack of resource, the lack of an important tool. Lack of resources safety nets. Check suspect areas at the beginning of the inspection and AOG the required parts. Lack of proper planning leads to making decisions on the fly. It is one of the main reasons people violate procedures. Order and stock anticipated parts before they are required. In this world of just-in-time delivery and overnight air, it is tempting to let the distributors handle the stocking of parts. However, tightly coupled systems are fragile. A maintenance problem on a freight aircraft halfway around the world may ground the aircraft you're maintaining. Know all available parts sources and arrange for pooling or loaning. Without a ready parts supply, maintainers may feel that procedures must be violated in order to get the job done. Maintainers are also very creative. Jobs tend to be completed despite the lack of parts. The idea is to use good planning to reduce pressure on maintainers to be creative. Maintain a standard, and if in doubt, ground the aircraft. The Federal Aviation Regulation 14 CFR 43, Subpart 4313, Performance Rules, is the standard of performance for maintaining aircraft. It has plenty to say about resources. It requires a current manufacturer's maintenance manual. It requires proper tools, equipment, test equipment, special equipment, and aviation quality materials. This rule supplies a technician backup when it is time to make the decision to ground the aircraft. A certain amount of pressure is appropriate, but too much pressure can cause a technician to make a mistake. If there is a generic hazard in aviation maintenance, it would be pressure to produce. Pressure to produce causes a drift to dangerous methods. Features of pressure to produce are completion of work despite lack of resources, supervisors condoning unapproved actions to get the aircraft underway, releasing aircraft with work undone. Signs of excessive pressure to produce are being asked repeatedly, "How long is this going to take?" Getting frustrated and angry during the job, wanting to go home. This airline ground accident happened in Taiwan to a U.S. airline. An aircraft was pushed back before the number 2 cabin door was closed and before the air bridge was retracted. So, how did this happen? Apparently, at the last minute, there was a gate call to accept 4 late show passengers. The cabin door had already been closed. The purser reopened the door without informing the captain. The captain then requests the tug to push back the aircraft. This very neatly removed number 2 door. What possessed the purser to open the door once it was shut, and why didn't he tell the captain he had opened it? People make decisions like these for a particular reason. The pressure to make on-time departure is crushing, and combined with an airline in fiscal duress, the situation begins to make sense. More than likely, the purser, knowing the airline needed all the help he could offer, thought it was very important to get the 4 late passengers on board the flight. They represented a significant financial stake. How much time did the purser have? He probably thought he had more than it turned out he did. Was he distracted once the passengers came on board? One thing we can speculate about the purser is, since he was an American crewman, he was fatigued due to circadian desynchrony, also known as jet lag, which would make him more tolerant of risk and cloud his decision-making. Pressure safety nets. Be sure the pressure is not self-induced. Self-induced pressure is the kind that can be self-reduced. The picture of the Coast Guard saving capsized boaters is a good example of when pressure is not self-induced. Anything short of life and death can be put into perspective and dealt with in a rational way. Communicate your concerns. One way to reduce pressure is to communicate your concerns to someone who is in a position to make a difference. Who knows first when a plan is not working? Is it the supervisor who hatched the plan or the mechanic who is implementing it? Supervisors want to know early on when things go bad. Ask for extra help. Extra help and other vital resources are generally only a request away. Your supervisor wants you to be successful, because when you're successful, he is too. Just say no. Saying no is a last resort. The idea is to be assertive, not aggressive, when you tell someone no. Mechanics as a group are not as assertive as we could be. We like to fix the plane and leave the conflict to the managers. We don't like having people in our face. The culture is can-do. Notice the range between passive and aggressive is along the horizontal axis of the chart, and performance is along the vertical axis. Assertiveness resides on this continuum between passive and aggressive. The one pole is the passive pole. It is a place where the person considers others' rights to be more important than his own. Someone operating at this pole is willing to compromise their standards and acquiesce to dangerous ideas like, go check the battery door. The other pole is the aggressive pole, where the person considers their own rights to be more important than anyone else's. This is where the person is offended and becomes angry. Angry people nearly always regret their actions after they calm down. Neither pole is productive. Assertiveness is between the two poles. It's where both parties' rights are respected. It's the place allowing teamwork and synergy. This mishap might not find its way to the headlines. An ambulance pushes 2 golf carts together, causing minor damage to the golf carts and the ambulance. You need to ask yourself the question, what caused the ambulance to squeeze the golf carts? Look at the aircraft's engine nacelle. See how it has pushed the ambulance forward? Why did this happen? Notice the red line painted on the ramp just behind the policeman. It defines a safety area where vehicles are not to park. What do we do as ramp or maintenance people who witness an ambulance park in our safety area? Obviously, there's a medical emergency in the terminal. Do we say, "Hey, you can't park there"? Or do we say, "Is there anything I can do to help"? The assertive thing would be to explain to the ambulance crew that it's very dangerous to park there. They would really prefer to park where the ride won't get dented. Lack of assertiveness safety nets. If it's not critical, record it in the journey logbook and only sign for what is serviceable. This is a Canadian safety net. In the U.S., we don't have journey logs. We do have minimum equipment lists and other ways to fly aircraft with inoperative equipment. The idea here would be to follow the company procedure for dispatching a less than perfect aircraft. Refuse to compromise your standards. This will keep you out of all sorts of trouble. It is certainly not pressure-free. However, do what is right, even when no one supports you. Even if you lose, you win. Not only will you be able to live with yourself, you may even save a life. It might even be your own. For instance, the Italian loadmaster. An officer asked him to exit the aircraft just forward of a spinning propeller. Is it possible there are procedures or rules to prevent such a thing? More than likely there are. Would the aircraft commander have been very happy if the loadmaster had said in a respectful way, "There is a rule preventing me from stepping out of the aircraft door with the left engine running. Please shut down the left engine and I'll be happy to check the battery door"? He probably would not have been overjoyed with the delay, but he more than likely would have done it. In hindsight, do you suppose the aircraft commander wishes the loadmaster had said something? Stress is a blessing and a curse. It is a blessing in that it motivates us to perform. Why do we do anything at all? We experience some kind of pressure to compel us to move. It may be pleasure or pain, but it's stress of some kind. Notice the level of stress is along the horizontal axis of the chart, and performance is along the vertical axis. If stress is low, it causes boredom and complacency. If stress is high, then it causes fixation and confusion. For maintenance people, it's probably more a matter of poor decision-making and confusion. Unresolved stress also tends to cloud our judgment, leading to more risky behavior. However, a moderate level of stress is appropriate. It causes a person to be prepared and ready to perform. A moderate level of stress may be when a deadline is looming, or a person's supervisor is applying moderate pressure to produce. Stress safety nets. Be aware of how stress can affect your work. Understand that moderate stress is good. Too little or too much stress can be an influence to make mistakes. Stop and look rationally at the problem. You can affect the outcome of some things and other things are out of your hands. It's a good idea to determine to which category your stressors belong. Determine a rational course of action and follow it. For the stressors you can affect, develop a plan. Things may not get better overnight, but at some point you should be able to dig out. Take time off or at least have a short break. For immediate stressors, taking a short break, eating, or drinking can allow a solution to form. Discuss it with someone. People who are not intimately involved sometimes have a point of view allowing them to see things that you miss. People generally have good ideas. 2 heads are better than 1. Ask fellow workers to monitor your work. When technicians are severely stressed, their teammates usually know why. Most people have a desire to help. Maintenance people are biased to fix things. If you ask your friends to back you up due to some life issue, they will be happy to do so. Exercise your body. What we feel due to excessive stress is our body's fight or flight reaction. Fighting is normally not very socially acceptable, but flight, as in exercise, is. The idea would be to exercise as a natural method to reduce the fight or flight reaction. Exercise pumps up our endorphins, our body's feel-good neurotransmitters. It is meditation in movement. After good hard exercise, you will often find you have forgotten the day's dilemmas and irritations, and concentrated only on your body's movements, resulting in energy and optimism. Lack of awareness or reduced situational awareness can be an indication one or more of the other human factor issues are in action, such as fatigue or distraction or lack of communication. Here's an example of apparently a maintenance crew was performing preventive maintenance on the landing gear. They had not pinned the nose gear, and when the gear was selected up, it functioned as it should and came up. A crew then used airbags to jack the nose of the aircraft. This is the lack of awareness part. In hindsight, we can say perhaps someone should have walked around the aircraft before applying the air. Lack of awareness safety nets. Think of what may occur in the event of an accident. It is not easy to anticipate events that have not yet happened. Brainstorm possibilities with colleagues, identify hazards associated with the situation, then consider the likelihood and severity of each hazard, then modify the plan to reduce the risk of the hazard. Check to see if your work will conflict with an existing modification or repair. It is the installer's responsibility to check for conflict because the installer is firmly rooted in the reality of the installation. The designer may not know of a conflicting modification or repair. Ask others if they can see any problem with the work done. Listen to your teammates. They will have a different perspective. For example, it can be the more inexperienced team members who see the flaw in a long-established plan. Norms in the context of the Dirty Dozen means our group has a better way to do this job than the published procedure. In the following case, someone discovered a very creative way to accomplish a task and save 12 hours of labor. On May 25, 1979, American Airlines Flight 191, a DC-10, crashed at the Chicago O'Hare Airport after losing an engine during takeoff. Improper maintenance procedures were to blame. The failure was a cracked flange on the engine pylon assembly, caused by a maintenance procedure. During the procedure, the engine and pylon were supported by a forklift, while some of the pylon's attachment connections to the wing were removed and others were left in place. During this procedure, the forklift's hydraulics leaked, so it had to be adjusted from time to time. At some point, it ran out of fuel. Later, tests showed under these conditions, leakage would allow a drift down of 1 inch in 30 minutes. During the investigation, it was determined that a movement of 1/2 inch would produce a 7-inch fracture of the flange. The resulting crash killed 271 people aboard the aircraft, as well as 2 on the ground. Norms, safety nets. Always work per the instructions or have the instructions changed. We tend to let it pass when the procedures are clunky and a workaround is required. We're used to it. Procedures are hard to change, people may not be interested, and in some cases we may be disciplined for not following the procedure. Maybe it's just easier to let it go. But what happens to the next guy when he encounters the same lame procedure? He has to learn the lesson all over again. If a procedure doesn't work or there is a workaround necessary, we need to report it in order to get the procedure changed. Be aware that norms don't make it right. It can take real courage to stand up to the group and point out their norm doesn't meet the rule or the published procedure. However, a little pain in the present can save major pain in the future. The unfortunate fact is there is at least one additional fatality not on the official list for American Airlines Flight 191. One of the maintainers committed suicide after the accident. The Dirty Dozen is a catchy title, but is it possible there are more than 12 human factors issues? These 12 are meant to stimulate the human factors discussion. What about illness and emotional issues such as anger, pride, or fear? What about drug and alcohol use? It is our hope this presentation will encourage you to openly discuss human error and those things that influence people to make mistakes. Errors are a part of life. Errors are natural and forgivable. It is the context of the errors that make them tragic. Maintaining and operating aircraft is a most unforgiving context. The reality we face in this industry is if we make even a very slight mistake, it may well cause a fatal accident.